Welcome to our deep dive into one of the greatest mysteries in planetary science. How do moons form in space? Today, we'll uncover the secrets behind Saturn's largest moon, Titan. Imagine a celestial ballet, where gravity orchestrates the movements of planets and their moons. These moons, like cosmic dancers, hold clues to the formation and evolution of our solar system. And among them, Titan stands out, a world shrouded in mystery, beckoning us to explore its depths. So how do these celestial objects, these moons, come to be? It's not like planets just order them online, right? The universe, my friends, is a chaotic and creative sculptor, and moons are born through a variety of fascinating processes. One way is through cataclysmic collisions, giant impacts that send debris hurtling through space. Imagine a young, still-forming planet being struck by a Mars-sized object. The impact is unimaginable, releasing enough energy to melt rock and fling molten material into orbit. This debris, over time, coalesces under its own gravity, forming a moon. Our own moon is thought to have formed this way, a cosmic scar from a tumultuous past. Then there's the more gentle process of accretion. Picture a young star surrounded by a swirling disk of gas and dust, the remnants of its birth. Within this disk, planets are forming, and around these nascent worlds, smaller clumps of material are drawn together by gravity. Like dust bunnies under a cosmic couch, these clumps grow larger and larger, eventually becoming moons. And let's not forget about capture. Sometimes a moon isn't born in the same neighborhood as its planet, but is instead a cosmic wanderer captured by the gravitational pull of a larger object. Imagine a rogue moon, perhaps ejected from its own solar system, drifting through the vastness of space until it encounters the gravitational embrace of a planet. It's a cosmic adoption, and it's thought to be how some of the more distant, irregularly shaped moons came to be. Now let's turn our attention to a moon that truly stands out from the crowd, Titan. Orbiting the ringed giant Saturn, Titan is a world of wonder, a place that pushes the boundaries of what we thought possible for a moon. First off, let's talk about size. Titan is a behemoth, the second largest moon in our solar system, even bigger than the planet Mercury. If it were orbiting the sun on its own, we'd probably be calling it a planet, no question about it. But size isn't everything, right? What truly sets Titan apart is its atmosphere. Most moons, they're like bare rocks in space, but Titan boasts an atmosphere thicker than Earth's, a hazy, nitrogen-rich shroud that obscures its surface from our view. And beneath that thick atmosphere lies a world that's both alien and strangely familiar. We've got mountains, valleys, and vast plains. But instead of water, liquid methane and ethane flow across Titan's surface, carving rivers and filling lakes larger than the Great Lakes here on Earth. And the chemistry? Oh, it's fascinating. Titan is teeming with organic molecules, the building blocks of life as we know it. It's like a giant prebiotic chemistry experiment just waiting for us to unlock its secrets. Then there's the possibility of a subsurface ocean, a hidden reservoir of liquid water beneath Titan's icy crust. Imagine that, an entire ocean, hidden from view, perhaps teeming with life as we don't know it. So how did Titan come to be this extraordinary world? Like a detective piecing together clues from a crime scene, scientists have been working tirelessly to unravel the mystery of Titan's formation. The leading theory suggests that Titan formed alongside Saturn, coalescing from the same swirling disk of gas and dust that gave birth to the ringed giant itself. Imagine a young Saturn surrounded by a chaotic cloud of material, and within this cloud, tiny particles began to collide and stick together. These particles, drawn together by gravity, formed larger and larger clumps like cosmic dust bunnies under a celestial couch. Over time, these clumps grew into moonlets, mini-moons orbiting the young Saturn. And then the chaos continued. These moonlets, drawn together by their own gravity, collided and merged in a series of cataclysmic events. It's a cosmic game of billiards, with moonlets smashing into each other, their shattered remnants forming the building blocks of a larger, more massive moon. And so, through this chaotic and violent process, Titan emerged, a giant among moons, its destiny forever intertwined with that of its ringed parent, Saturn. Chapter 4. A breathable blanket, the enigma of Titan's atmosphere. Now let's talk about Titan's most striking feature, that thick, hazy atmosphere. Most moons, they're practically naked in space, but Titan's got layers, and those layers tell a fascinating story. First off, there's the composition. Unlike Earth's atmosphere, which is mostly nitrogen and oxygen, Titan's is dominated by nitrogen, with a healthy dose of methane thrown in for good measure. It's a recipe for a hazy, orange-hued sky, and it's unlike anything we see elsewhere in the solar system. But how did Titan get such a thick atmosphere? It's a question that has puzzled scientists for decades, and while we don't have all the answers, we've got some pretty compelling theories. One possibility is that Titan's atmosphere is a remnant of the primordial cloud of gas and dust from which Saturn and its moons formed. As Titan coalesced, it could have captured some of this gas, forming a thick atmosphere early in its history. Another possibility is that Titan's atmosphere was delivered later, through a process called outgassing. As Titan's interior warmed, perhaps due to radioactive decay or tidal forces from Saturn, volatile compounds like nitrogen and methane could have been released from its rocky core, replenishing its atmosphere over time. And let's not forget about the role of comets and asteroids. These cosmic wanderers, carrying their own icy payloads, could have collided with Titan over billions of years, delivering even more volatile compounds to its atmosphere. It's a cosmic puzzle, and we're still piecing together all the clues. But one thing's for sure, Titan's atmosphere is a testament to the dynamic and ever-changing nature of our solar system. Chapter 5, Titan, a window into moon formation and early Earth. Now you might be thinking, okay, Titan's cool, but what can it tell us about the bigger picture? Well, my friends, Titan is more than just a fascinating object in our cosmic backyard. It's a key to understanding how moons form and evolve, and it even provides clues about the early Earth. First off, Titan shows us that large moons can develop and maintain complex atmospheres. This is important because it challenges our assumptions about what makes a world habitable. We used to think that only planets could have substantial atmospheres, but Titan proves that moons can too. Second, Titan's methane cycle, with its methane rain, rivers, and lakes, is like a giant Earth science experiment. By studying how methane behaves on Titan, we can learn more about how Earth's climate system works, and how it might change in the future. Third, Titan's organic chemistry is fascinating because it gives us a glimpse into the possible building blocks of life. The organic molecules found in Titan's atmosphere and on its surface are similar to those that were present on early Earth before life emerged. By studying Titan, we might be able to learn more about the conditions that led to the origin of life on our own planet. And finally, Titan's subsurface ocean is a tantalizing possibility, because it suggests that life as we don't know it could exist elsewhere in the solar system. If there's one thing we've learned from exploring our own planet, it's that life finds a way, even in the most extreme environments. Chapter 6, Dragonfly Unveiling Titan's Secrets. So, we've learned a lot about Titan from afar, but the best way to understand this enigmatic world is to go there ourselves, or at least send our robotic emissaries. And that's exactly what NASA is planning to do with the Dragonfly mission. Imagine this, a drone, powered by nuclear energy, flying across the skies of Titan. It sounds like something out of science fiction, but it's becoming a reality. Dragonfly is scheduled to launch in 2027 and will arrive at Titan in 2034. This mission is going to be epic. Dragonfly will spend years exploring Titan, hopping from one location to another, studying its atmosphere, its surface, and maybe even peeking beneath its icy crust. One of the key goals of the mission is to study Titan's chemistry. Dragonfly will analyze the composition of its atmosphere, its lakes, and its surface materials, searching for clues about the origin of its organic molecules and the possibility of prebiotic chemistry. Dragonfly will also investigate Titan's methane cycle. It will study the formation and evolution of its methane clouds, rain, rivers, and lakes, helping us to understand how this alien climate system works. And of course, Dragonfly will be on the lookout for signs of life, both past and present. While the mission isn't specifically designed to find life, it will be exploring environments where life as we know it could potentially exist, such as near hydrothermal vents on the ocean floor or in subsurface aquifers. The Dragonfly mission is a testament to our insatiable curiosity, our desire to explore the unknown, and our quest to understand our place in the cosmos. Chapter 7, Titan, a world of endless wonder. Titan is more than just Saturn's biggest moon. It's a laboratory for studying early Earth-like conditions and moon formation. Its mysterious origins, thick atmosphere, and liquid lakes make it one of the most fascinating objects in the solar system. Understanding Titan may even help us find life elsewhere in the universe. It's a world of endless wonder, a place that challenges our assumptions about what's possible and inspires us to dream big. Would you ever want to explore Titan in person? Imagine standing on the shores of a methane lake, gazing up at Saturn's rings in the sky. It's a journey that would redefine our understanding of the cosmos and our place within it.